This is section 2.1. We're going to be talking about sets. A collection of objects whose contents can be clearly defined. That's the definition of set. Elements are members in a set. Those are the objects in a set. A set must be what we call well-defined. What that means is the contents can be clearly determined. Maybe a better way to explain well-defined is talk about a set that's not well-defined. For example, if I say I want to talk about the set of comfortable room temperatures, well, somebody might think that 90 degrees is a comfortable room temperature. Somebody else might think that 60 degrees is a comfortable room temperature. But it's hard to know unless somebody is actually talking about these are the comfortable temperatures. So if you have a set that depends on who you're talking to, that's not well defined. So we're not going to talk about those kinds of sets. The order in which the elements are listed is not important. So for example, if I have the set 1, 2, 3, that is going to be the same as the set 3, 2, 1. Those are exactly the same set. Doesn't matter the order in which I write the set elements. Capital letters are generally used to name sets. We have different methods for representing sets. One method is a word description. For example, if I say set W is the set of the days of the week, everybody knows what we're talking about. Another method for representing sets is what we call the roster method. Roster method means listing out all of the members of the elements of the set. So for example, I could say the set W is equal to Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. When we use roster method, we put commas between the elements of the set, and we use braces. So you have to use braces for a set. Write a word description of the set. So let's say, for example, we have Washington, Adams, Jefferson, Madison, and Monroe. A word description would be P is the set of the first 5 presidents of the United States. Be specific when I ask you to write a word description. These are not just presidents. They're not just presidents of the United States, but they're actually the first 5 presidents of the United States. Write using the roster method. Roster the method is where we use the braces. The set of U.S. coins with a value of less than $1. So in the U.S., we have pennies, we have nickels, we have dimes, and we have quarters. We also have a 50-cent piece. We do have dollar coins, but we want less than $1, so we wouldn't count the dollar coins. Set builder notation looks like this. This is how this is read. We would say the set W is or is equal to, the braces mean set, the set of all x's. The straight up line is such that x is a day of the week. So one more time, the set W is the set of all x such that x is a day of the week. This right here tells us what variable we're going to use over here. After this line right here, it describes any conditions that we have on the variable. So for example, in this case, it has to be a day of the week. Suppose I have set builder notation, I want to go to roster notation. Roster notation is where we list everything out. So what I'm going to do, I have the set of all X such that X is a month that begins with the letter M. So I want to list out in braces all the letters that begin with M, or all the months that begin with the letter M. So go through the months: January, no; February, March, April, May, June, July, August, September, October, November, and December. So the months that begin with the letter M are March and May. The empty set. Another name for the empty set is called the null set. It is a set that contains no elements. There are two different ways of representing it. We can use the braces with nothing in between, or we can use a circle with a line through it. Be very careful, this does not mean 0. It means the empty set. Do not put braces around a 0 with a line through it. That is not the same thing. This set actually has an element, and it has the empty set in it, so this would be incorrect. Examples of empty sets: the set of all numbers less than 4 and greater than 10. There is no number that's smaller than 4 and greater than 10 at the same time. The set of all X such that X is a fawn that speaks. Unless we're talking Disney, which we're not, there are no deer, baby or not, that talk. Which of the following consists of an empty set? This is not empty. It has an element. It has the element 0. This is not the empty set. It's not a set at all. It is the number 0. The set of all X such that X is a number less than 4 or greater than 10. This is not empty. 3 is less than 4. 15 is greater than 10, so it has elements in it. The set of all X such that X is a square with 3 sides. A square has 4 sides, so there is no square that has 3 sides, so this set would be empty. This symbol right here, which looks kind of like a capital letter E, is used to indicate that an object is an element of the set. We use this symbol to replace the words is an element of. If I put a line through it, like this, what that means is not an element of. Determine whether each statement is true or false. R is an element of the set A, B, C, keep on going until you get to Z. Is that true? Well, these are letters of the alphabet, and R is a letter of the alphabet, so yes, this would be true. R is an element of the letters of the alphabet. This one says 7 is not an element of the set 1, 2, 3, 4, 5, and that is true. 7 is not an element of this set. Be careful with this because it says the set A is an element of the set A, B, and that is false. It does not say A is an element of the set A, B. This would be true. If I had the set, let's see if I can draw that better. The set A is an element of the set B, comma, the set A, then that would also be true, where the set is an element of the greater set, so that would be true. But this over here, the set A is an element of the set AB. That is false. Ellipsis, that's the dot, dot, dot. That means keep on going in the same way. So we're going to use each, or we want to represent each of the following using the roster method, but it's sometimes not easy to represent numbers that keep on going in the same way, so we use the ellipsis. Set A is the set of all natural numbers less than 5. Well, natural numbers are the counting numbers. They start with 1. So we would say A is the set 1, 2, 3, 4. We want to be less than 5, so we would not include the number 5. B is the set of natural numbers greater than or equal to 25. So B would be the set greater than or equal to 25. So we have to start with 25. 25 is an element. 26, you should probably do 3 or 4 elements before you do the dot, dot, dot. And that means keep on going in the same way. E is the set of all x such that x is an element of the natural numbers, counting numbers, and x is even. So the first or smallest natural number that is even is 2, then 4, then 6, 8. Keep on going in the same manner. I'm going to stop here for the end of part 1.